Hi, and welcome to my talk about how to architect for continuous delivery. First, to myself, my name is Romano Roth, and I am the Chief of DevOps and a partner at Zölke. I work now for 21 years for Zölke. I joined Zölke directly after university, became a junior .NET engineer, then an expert software engineer, then a lead software architect, and finally I became a consultant. And one thing that was very close to my heart is how can we continuously deliver value? How can we ensure that the quality is good of what we are going to deliver, and how can we automate things? And when the whole DevOps movement started, I jumped right on top of that, became one of the organizers of the DevOps Meetup Zurich, which is a monthly meetup we are doing. And I'm also one of the organizers of the DevOps Days Zurich. The DevOps Days is a 2-day conference, and all over the world, in all of the big cities, there are DevOps Days conference, and I am the president of the DevOps Days Zurich. You can see that DevOps is something that is very close to my heart. That's also why I have my own YouTube channel with over 100 videos all around DevOps, architecture and leadership. And I also post and tweet a lot on the social media channels. If you want to learn more about DevOps, then please follow me on these channels. In my projects, I work for different clients in different industries, and I'm doing DevOps transformations. And when I'm in such a consultant mode or in such a DevOps transformation at the client side, then I usually see exactly this picture, what we can see here. The business, together with the clients, they have very, very bright ideas. They are putting these bright ideas into Word documents and into Jira tickets, and then they throw it over the wall of confusion to the development team. The development team looks at these requirements and they say, hey, if you want to have that, we can implement that, and they are going to implement it. And then they throw it over the wall of confusion to the testing team, and the testing team looks at that, looks at the requirements. It's not the same, but they test something, it's green, and they throw it over the wall of confusion to the operation team. The operation team looks at that and says, whoa, this will never work in production, but somehow they manage to get it to work, and they throw it again over the wall of confusion to the client and to the business. And the business is, or the client is like, what is that? This does not solve our problem. This is not what we wanted. And you can see in this picture, this blue line there, this is the value stream, and the value stream is broken by these walls of confusion, and they are coming from the silo organization. We have the business, development, QA, and operation silos. Usually also have quite a lot of legacy systems, technologies, and this all leads to inflexible and slow processes. There is no alignment in here. Every team is working on their own goals, and usually in such an environment, security and also quality is something that is done when things are in production. Also, what we usually have is quite a lot of cultural resistance, and regulatory and compliance also plays a huge role. Now, where do these challenges come from? These challenges are coming from the projects which we are doing. In the past, we have done projects in the waterfall mode. We have planned, designed, developed, deployed, reviewed, tested, and launched in large batches our projects. There, the scope, the budget, and the time was fixed. Then, around the year 2000, some bright people say, no, this is not how we can do software development. We need to go agile. And we went agile. Now, time and budget is still fixed in our project, and the scope is variable, and we are delivering in smaller increments. but we are still doing projects. But our clients, they want to have products. They don't want to have a project. Now, to understand that, we need to a little bit dive deeper into that. So a project always has a start and an end. It has a fixed set of features that are going to be delivered and also resources which are applied to a project. So I want to have these 10 features in a half year for, let's say, 200,000 euros. This is a project. So a project is focused on output, maximizing the stuff that gets delivered, features, user stories, tasks, and code. On the other side, we have the project. In the project, we focus on the outcome. We want to solve the problem of the customer. We want to change the behavior of the customer. So it is very outcome focused, and we want to understand the problem of the customer. So we want to deliver that one feature that solves the problem of the customer. So we want to do products, and DevOps is very good when it comes to deliver products, because DevOps is a mindset and a culture and a set of technical practices which allows us to organize ourselves across the value stream, bringing all the people together which work on a product so that we can continuously deliver this product. When we talk about DevOps, we also need to talk about the people and the term DevOps. I already mentioned DevOps aligns us across the value stream and brings all the people together that work on a product, on a value stream. The term DevOps implies that it's development and operation. And of course, there are some smart people out there which say, no. Nowadays, security is also very important, so we need to fix that term. Let's call it DevSecOps, development, security, and operation. How also this conference is called. And then there is another group of people which says, oh, no, the business is very important. The business, they are giving us the money. And that's why we need to call it BizDevOps, which is business development and operation. And you can see this discussion leads nowhere. We need a term like DevSec, Biz, Arc, Comp, QA, Ops, and I'm pretty sure I have forgotten someone. We can also call it DevXOps or DevStarOps, or we just call it DevOps, because DevOps is about bringing all the people, process, and technology together to continuously deliver value. This is what DevOps is. So, why should you care about DevOps? Now, in the year 2000, some startups with funny names like Google, Facebook, Amazon, Netflix, they started to use DevOps practices. Nowadays, they are dominating the market. At the moment, you can clearly see that Tesla, SpaceX, Waymo is also using these techniques to create cyber-physical systems, so systems which have hardware, software, and electronics in there. And I'm pretty sure in 5 years we will see that these companies are dominating the market. Do you want to get an example? Here you get an example of Elon Musk, which is tweeting about the self-driving release of his software. So he's tweeting on the 7th of October 2029 that FSD Beta 10.2 will be rolled out to roughly 1,000 owners with a perfect safety score. What does that mean for us? It means that he has the software modularized in the cars, so there is a module for self-driving and he can update that over the air. It also means that he is constantly monitoring how people are driving and he can distinguish between people who drive very good and people who drive not so good. And he is able to target a certain group of people based on that data. This is a so-called canary release. Now, on the 15th of October, he then tweets, everything was okay with the 10.2 release, and we are releasing now 10.3 to a larger group of people. Again, this means that he was able to monitor the system, or Tesla was able to monitor these cars. Then on the 24th of October, he says, ooh, there was some problems with the 10.3 release. We are going to roll back to 10.2. Now here we need to quickly stop. So here we talk about cars on the road which are regulated, and he is able to do a rollback of the software. Many companies are not in that position to do that, but he does that with hardware and software. Not even 24 hours later, he says, everything is okay. We are going to roll out 10.3.1 with the bug fix, and we do a fix forward. So really amazing what Tesla is able to do there. So to be able to do such things, you need DevOps. And DevOps has been analyzed scientifically with the book, The Science of DevOps, Accelerate, which I can highly recommend to you to read. In this book, they have found out 24 key capabilities which drive improvements in software delivery performance. They have categorized these 24 key capabilities in five categories. There is the continuous delivery capability, where it says you need to have everything under version control, you need to have deployment automation, continuous integration, so reintegrating the code, trunk-based development. Science has found out that trunk-based development is the way to go, just to say. Then test automation, test data management, shift left on security, and the continuous delivery capability. So this is very important. Then based on that, you need to have some architecture capability, like loosely coupled architecture and empowered teams. I always say you should create a loosely coupled architecture around modules with clear inputs and clear outputs with teams of maximum 5 people. Then they are also empowered and they can deliver continuously. Then we have the product and process capabilities with customer feedback, value stream mapping, so organizing across the value stream, working in small batches, and team experimentation. Then the lean management and monitoring capability, and here, very important, the scientists has found out that change approval boards are in the best case for nothing. In the worst case, they will slow you down very, very much. So there is not a benefit in having change approval boards. Monitoring is very important also for the productive notification, so that you find the bugs before the clients do that. Then work in process limits and visualizing the works. This is the Kanban boards and also the Scrum boards. Then the cultural capabilities are very interesting. There you have the Vestrum organizational culture, where we distinguish between 3 different types of companies. There is the pathological company, there is the bureaucratic company, and there is the growth company. Pathological, there when an error or when a failure happens, the person who reports the failure or has done the failure will get shot. In the bureaucratic company, the person who has done the failure or has reported the failure will go through bureaucratic, long-lasting processes. And in the growth companies, when someone reports a failure or has done a failure, he will get celebrated because everybody has learned something. And of course, all of the companies want to be in this grows companies, but usually companies are bureaucratic. This leads us to supported learning. You want to continuously learn, collaborate across the teams. You want to have job satisfaction. And for all of that, you need to have transformational leadership. So these 24 key capabilities, they are very, very important when it comes to architect for continuous delivery. And you will see some of these key capabilities I will pick and dive a little bit deeper in my presentation today. Already identifying these 24 key capabilities was quite amazing, but they also draw that picture which you can see here, and they also found out the relationship between these key capabilities. I usually say this is one of the most important pictures when you are going to do a DevOps transformation or when you architect for continuous delivery, because it shows you on the on the right side, what you want to achieve or what you can achieve when you do the things on the left side. And this is a very important picture when you are going to architect for continuous delivery. So with that, what are the benefits of DevOps? Also, again, here science has looked at that. There is the State of DevOps reports, which is done on a yearly basis. And here we are going to compare the low performer versus the high performer. And you can see the numbers are massive on deployment frequency, lead time, and so on. This all boils down to the benefits which all of the CIOs nowadays want. They want to have a faster time to market, more value for money, higher quality, higher customer satisfaction, and top qualified employees. And these are the benefits you get when you implement DevOps. So now, when you are going to implement DevOps, this is nothing else than modern software development across the value stream. For that, we have here this infinity symbol, this DevOps symbol, where you can see that in the planning step, you need to have agile requirements engineering and backlog management. You need to have in the coding agile software engineering practices, which you should apply. Everything, and really everything, needs to be under version control so that you can fix forward or roll back things. And then you have in the build step the continuous integration, that you're continuously integrating build and test automation, and also the application security. In the testing, it's very important to have test automation and test data management, that you have the synthetic test data and not use the production data. In the deploy, we need to have a staging environment, a production near environment, and of course deployment automation, which needs us to release. In DevOps, we are distinguishing between deployment and release. Deployment is bringing the code into production with the feature toggle off, and releasing means we are going to switch on the feature toggle. This is exactly what Elon Musk did with Tesla. He switched on the feature toggle for a certain group, and this is called canary releases, and you need to have feature toggles for that. And it enables you to do dark launch, because he delivered, of course, that software to certain cars, but only a few of them were able to use that feature. This brings us to the operate, where we want to have cross-team collaboration, so that we really, across the team, work together in resolving problems. And we need to have proactive detection, which means we want to find the problems before our customers do. And for that, we need to have a full stack telemetry with visual displays and federated monitoring, so that we can make sense out of the data that we get. And this goes back into the agile planning and into the agile requirements engineering, because we should always base our decision on data, numbers, and facts that we get from our monitoring system. So the first thing I want to dive a little bit deeper is built-in quality, because that is essential for architecting for continuous delivery. When you look at the Musk companies like SpaceX, Tesla, Neuralink, the Boring Company, Elon Musk is investing into the new products, and 50% of that invested money goes into automated testing, because only with automated testing you can deliver that fast innovation to the market. And this is quite a high number. I'm pretty sure that the numbers in your company are much lower than these 50%. So now we need to have a look at the testing. Usually we test in a V model, which you can see there, where we have delayed feedback. Usually it happens that way, that a requirements engineer is writing a feature, then another requirements engineer is writing a story, and finally a developer writes the code. If we are very lucky, then the developer also writes some tests for that code. Usually we are not that lucky in that model, and no test is written on code level. And then the story goes to a tester, which tests the story, and then another tester will test the feature. Usually in between that, writing a feature and testing the feature, it can easily be 3 months, 6 months, or even a year. So it's delayed feedback. When we go into agile testing, which I highly recommend in a DevOps approach, then we are going to define the feature already with behavior-driven development, where we define the acceptance criteria of a feature in a given, when, then form. Given the following state, when the following action occurs, then I want to have that result. So when we have the acceptance criteria in that form, also for the stories, then it's very easy for us developers to create out of this specification automated tests. Always a good tool for that. And this, what we are doing there, is called test-driven development. So we write first the test. Even when we don't have the acceptance criteria in a BDD form, we should always write first the test, then the implementation, and then do the refactoring. This is what TDD is all about. You can see that in there. So you should always write the test, then the code, and this means we are shifting left the whole testing of a story and also of a feature. And this is why we usually talk about the shift left in testing. For that, we also need to have a look at the testing pyramid. Usually in traditional testing, the test pyramid looks like the one on the left side. You have slow and expensive end-to-end tests, which are done manually. You have only some integration tests and very few unit tests, which are fast and cheap. When you apply agile testing, and you could see that when you have the specification of the acceptance criteria written in a BDD form, and when you apply test-driven development, so always first write a test before the implementation, then you get a massive amount of unit testing, because everything is tested, and some integration testing, and only a few end-to-end tests. And this brings us to, when you look at the traditional test pyramid, this there the focus is on finding every bug, where on the agile testing pyramid, there the focus is on preventing bugs. So it's a risk-based approach which we are applying. Again, when we go into our infinity symbol of DevOps, this means that in the planning we are doing behavior-driven development. So we specify our acceptance criteria already in a form which are testable. Of course, definition of ready is very important in that case. And then when we go to code, then we apply test-driven development. We always write first the test and then the code for that. This brings us to the build. There we are using unit testing, of course, and also the application security. So we do container scanning, license scanning, and all of that. And then in the testing, we of course have the definition of done, which is important, and the whole test automation, including also the test data management with the synthetic test data. When we then deploy, production testing is a very important step that we are having there. Even if we don't release, we should always apply a subset of the tests also in production. When we are going to release, then cross-team collaboration is again important. And of course, in Operate, we want to detect the problems before our clients do, which leads us to the continuous monitoring of what we have done so that we have, that we have the data which is needed for the planning step. So, building quality is one cornerstone which is important for continuous delivery, for architecting for continuous delivery. What is also important is built-in security. This is really an important thing, and here we are in the Conf42 about DevSecOps. So, when we look at continuous delivery pipeline, then usually we talk about the CI/CD pipeline, which is continuous integration and continuous deployment. I usually say it's far more. It's your continuous delivery pipeline, because in the beginning you have the continuous exploration with ideation and backlog management and requirements engineering, and at the end you have the release on demand where you are going to switch on the feature toggle. So this is the continuous delivery pipeline. And you can see in such a continuous delivery pipeline, you have quite a lot of tools which need to be integrated with each other. Of course, there are vendors out there which promise you to cover the whole continuous delivery pipeline. They are coming with their DevSecOps platform. Yeah, well, when you take a close look, and I have done that in a video series with 25 videos, I have done that together with Patrick Stego, and I analyzed how we can implement DevSecOps pipeline with GitHub and also with GitLab. And you can see how such a pipeline can look like. You have, of course, merge request. You use the software composition analysis. You want to know what kind of libraries are there and what vulnerabilities you have in the libraries which you are using. License compliance is very important. What kind of licenses do you use in all of these libraries? And also the static application security testing. We are going to statically analyze our code. The container scanning is important, and we need to scan our code for secrets. Then when we have deployed, then of course we apply dynamic application security testing, where we try to break our application security-wise. And of course, when we are in production, we need to apply scheduled pipeline, where we execute the pipeline again and again, because in the meantime, with that version which is in production, there could be already some vulnerabilities. As said, with Patrick Stego, I created 25 videos all around how to create with GitLab and with GitHub such a DevSecOps pipeline, and we are also comparing those two pipelines together. So this brings us again to our infinity symbol. When we are doing continuous security, then it's important in the planning that we do the threat modeling, so that we analyze what are the attack vectors, what are the threats which we have, and how can we mitigate that. When we are going to code, we need to do merge requests or pull requests. Then when it comes to the build step, we apply application security in there. Everything is in there, like security testing, SAST, license scanning, container scanning, secret detection, all of that. and then we apply dynamic application security testing. Of course, in production, we will do penetration testing, and again, we do cross-team collaboration to find the problems. It is essential that we do proactive detection when we operate the product. We want to find security vulnerabilities before our customers do, and for that we need to continuously monitor our system security-wise. But not only security is important, also operability is a very important thing, because in DevOps we want to do you build it, you run it. And this means, as I already mentioned, proactive detection. This means that our monitoring system need to alert us about condition based on our tolerance thresholds which we have, and for that we need to have a good monitoring system. Also, disaster recovery is a very important thing. Usually disaster recovery procedures are not really in place and also not rehearsed on a regular basis. And of course, based on that, we need to have a notification strategy. I also mentioned cross-team collaboration. What we don't want to have is that only operation takes care about the production and owns the incident process. We want that the team owns the production, so that we can work across the value stream, and that we together respond on production failures and also hold incidents post-mortems. Now, the monitoring. I already mentioned that. This is a very important thing, and I want to quickly show you how this has evolved and why everyone is now talking about observability, because that's a cornerstone when you want to architect for operability. In the past, we had two-tier system. You had the UI and the database, and there you used monitoring. You had the metrics, so database size or file system size, or even CPU metrics, and you had your log statements about the health of the application. These things we still have, but nowadays we have, of course, three-tier application where you have a UI and a mobile application, then you have an application server, and behind that you have a database. Here you need to do application monitoring with traces, because you need to know where was the request coming from, UI, mobile, and of course you need to do infrastructure monitoring based on that, because now you have not only a database, you also have an application server. And then nowadays we have distributed service-oriented application where you have UI, mobile, third-party APIs, and so on. Usually you have an application gateway, then you have different services or even microservices, and behind that you have databases. And this puts quite a lot of challenge on that, because here you can have some weird behaviors in such a distributed system. And here we are talking about observability. Also here we usually also use AIOps to make sense out of the massive amount of data that we are getting out of that. So we need to architect for operability. This leads us to this infinity symbol, where you can see when we are planning, we already need to architect for operability. We always, when we are architecting a system or a subsystem or a microservice, we need to think by ourselves, how is that going to be operated in production, and based off that, we define the architecture for that. And then when we are going to code, we need to build in application telemetry. Also the developer needs to think about that, how to get the data out of that into the logging systems. We need to apply infrastructure as code. In the end, everything should be code. This brings us to the build step, where we have the continuous integration again, build and test automation, and also application security. Test automation is applied, and test data management. This brings us to deploy, where we need to have a production near environment, also to test the operation part, including also test automation, deployment automation. And of course, we need to have canary releases with feature toggles and dark launches. In operate, we need cross-team collaboration and proactive detection. And it is absolutely essential that in the monitor step, we have that full stack telemetry with the visual displays and federated monitoring. So now we saw that we need to continuously test, do continuous security, architect for operability. This is quite a lot to do, and therefore we are going now into the chapter about building a platform. Now, as I said, modern software development is a continuous process across that value stream that you see there. And you remember that I said DevOps is a mindset and a set and a culture and a set of technical practices. And these are the technical practices which we need to apply in order to continuously deliver value and in order to architect for continuous delivery. And yes, this is quite a lot which we need to do. That's wow. Now, it even gets harder because you remember we said you build it, you run it, which means you take care about the infrastructure, cloud, on-prem. You need to take care about the runtime, Docker, Kubernetes, VM. You need to take care about the CI/CD pipeline, GitLab, GitHub, CircleCI, or whatever you want to use, monitoring, Prometheus, Dynatrace, Datadog, and whatever you want to use, security with Snyk, SonarQube, and so on. And you also need to have tools like Jira, Confluence, Miro, and so on. And of course, you need to apply cost management across that, especially when you are in the cloud. And maintenance of all of these tools is also very important. And you need to provide access and security to all of these tools for your developer or your team members. And yeah, just forgot, you also want to implement an application. And there it is, your application where you want to implement some features. And yeah, this is quite a lot for implementing just a feature. And the thing is, every team has such a stack. Usually in bigger companies, when you scale that up, when you scale up DevOps, this is quite a lot which you see there. And you can see this leads to some inconsistencies and redundancies when it comes to these platforms. Every team reinvents the wheel. There is also a lack of operational experience. No synergies are used, and it's not easy to move people across these teams. And the complexity of these tools is very high. And this is why everybody speaks about the cognitive load, which is very high on these people. So now we are here. Are we doomed? Can we do DevOps, or should we go back to the silo organization? No. Let me quickly explain how we do that nowadays. So nowadays we are talking about platform engineering. Platform engineering is here to enable DevOps or DevSecOps in the product teams. What you have is you have a platform team which builds a product. This is called the platform. So there you see it. It's an example. This platform provides application runtime, so the environments where things are run, for example, a Kubernetes cluster. And it also applies, it also has DevSecOps built in. So there are already DevSecOps things implemented, like license scanning, like container scanning in the platform. So a lot of standardization is given by the platform. You also have access and identity in there, centralized security with web application firewalls, gateways, and so on. And of course, the whole monitoring and observability stack is delivered by the platform. And of course, with such a platform, you can also implement funny things like AI and large language models. So this enables quite a lot. As I said, this is a product that is given, sort of also a service that is given to the product teams. The product teams, they are building and running and maintaining their products on top of this platform. This does not mean that the platform team creates the CI/CD pipeline or monitors the application. No, absolutely not. The teams are doing that. The platform team just gives them the platform where they can build upon that. A standardized platform which generates value for these teams. And this means that the product team can do DevOps, the cognitive load is lower, so they can generate value for their customers, and the platform team generates value for the teams. Now, some of you might say, this is another silo. No, it is not, because the platform team creates a product, so a service for the other teams. The teams, they need to operate their own product, so they have the operation directly in there. The platform team just creates the platform so that the teams are enabled to deliver their products. This is a very important thing. If you don't follow this rule, then of course you will just introduce another silo and another wall of confusion. When you look at the market and also at Gartner, BCG, McKinsey, all of them are saying that platform engineering or building such a platform is very important in the upcoming next 5 years, which we will have, where they, for example, will say that a lot of companies will build up these platforms. So, clear recommendation into this direction. This brings us to the summary, how to architect for continuous delivery. First of all, you need to go away from that projects mindset into a products mindset. We want to put the customer into the center, and we want to solve the problem of the customer, and we don't want to do projects for our customers. Then it is very important to apply DevOps or DevSecOps. This is about bringing all the people, process, and technology together to continuously deliver value. And for that, we need to apply continuous testing and building quality. We need to build the quality right in from the beginning. We need to shift left the whole testing so that already when we are writing our specification, we write it in a form that is testable. And this brings us to continuous security. Again, here we are also shifting left the whole security. It is built in directly. When we architect, we do threat modeling, and then when we are going to code, there we are going to test quite a lot of things on security problems. And the fourth thing is, you can see this is quite a lot of things that teams need to do. This means we need to standardize all of that, and here we are going to apply platform engineering and creating a platform for our product teams. As you can see, we are entering the age of industrialization of software development. Platform engineering is the key to build this platform which enables the teams to do DevSecOps. And this is the way how you can architect for continuous delivery. Thank you very much.